All right, so we're going to go over how to use LaserTram Z multi-collection. This is specifically written for data that comes off the new multi-collector in time-resolved mode. So that looks something like this, saved as a CSV file. All right. If you haven't installed Anaconda Navigator yet, or just downloaded the software, there is another video for that in this YouTube channel, which you can refer to before doing this. So I'm just going to open up a terminal here, and I'm going to cd LaserTram Z multi-collection. So I'm just navigating to a different folder. Okay, there's all my files, and I'm going to open Spider, which is just an IDE to run this program. You can just type Python and then the file name, which I'll actually do in the next video just to demonstrate that as well. But this allows you to see the code and everything like that, which is kind of how I'm used to doing it. So once you open the file, which you can navigate to using the open file button, just hit the run or play button, and you get a screen that looks something like this. So this is the screen you should see. We have some sliders here, so we need to upload our data. So I'm just going to copy this path, input it. If your path name automatically puts little quotations here, go ahead and delete those. All right, so you should get this little pop-up window, and this allows you to put in the masses or the isotopes for every collector that you used. And it should automatically detect how many collectors were active. And these are listed, these are listed from high mass to low mass, going from left to right, top to bottom. This Faraday and IC option just allows you to choose whether that, well, it was originally written so that you could choose which collector was which, and we could convert over to all the same units. For the new, everything gets put out in voltages, so if that's the case for you as well, just leave all of these as Faraday. All right, so I'm just going to go ahead and type in all my masses here. Oops. All right, and whenever you get done with one of these last ones, don't hit accept detector array. Make sure you press enter so that it reads it, and hit accept detector array. Okay, so that loads the data in, and you should get this blank table here. All right, so now I'm just going to click up on one of these, choose some analytes to have a look at. Okay. And here we are. So these are the raw intensities. These are the isotope ratios, which are selected over here. So for instance, if I wanted to see 735, I could do that by selecting the appropriate box on the left. And then this graph over here is always going to show you the 207-206 ratio. That's never going to change. All three of these you can zoom around by panning. You can select these magnifying options that will allow you to zoom in and out on just the X and Y, or both. You can reset the graphs like this, and you can download them with this little download button here. Okay, so now to select an ablation interval, what I basically need to do, or what you need to do, is move these sliders that are here, that are up here at the top, are also down here at the bottom, but I just found them to be less useful down there. Or over to the left. So that's how you move these sliders. You can also click, and this changes them in 1 second intervals. You can also highlight, which I find to be pretty useful. Highlight those numbers and click. And of course, we can drag the sliders. The issue is the resolution on dragging is not very fine. So it has limited use, but in terms of getting a single ablation dialed in, it's not going to be too terribly useful. And then, of course, we have the background intervals here and dashed lines, which you can also change. This ablation start true allows you to project the regression, a lead-uranium ratio regression, back to before the start of your ablation interval. I implemented this just to, sort of stick with the assumptions that we're dealing with in laser-induced elemental fractionation. I find that it's actually not very good to project back past that ablation interval for a variety of reasons. One, your uncertainty blows up quite a lot because your confidence interval is drastically increases outside of the bounds of the regression. And the ratios just kind of seem to be more unreliable or less consistent in the standards. So you can just hit this lock back projection button. It should be on by default, and it will move that projected value and just lock it onto whatever the ablation start is. So move that back. Okay, and then if you want a first order regression or an exponential regression, you can hit these two buttons here. You can log the analyte intensities using this button. Gotta update here. So there they are. This is your integration time for your isotopes. Right now, you only get one integration time. I don't know how your machine outputs integration times, whether I need to implement an option to do multiple integration times, but right now, that's how we're going to do it in this program. You can choose the total counts approach, which I've outlined in the README, or the means and regression approach here. I'm not going to get into the details of that. You can change the power of the resulting confidence ellipsoid for all of these analyses by changing this value to get the common 95% confidence interval. You would just leave that at 0.05. So when I'm happy with my ablation interval, I'll hit evaluate interval, and you should get this. Screen that pops up. So this shows the fitted regressions. Right now we only have first order. We only selected 638. There it is. These are the residuals for that those regressions visualized here. If I chose exponential, which I will do, you would see that as well. Here are the confidence ellipsoids for Tara Wasserberg and Wetherhill, and here are the regression stats. Everything here is static, other than, of course, moving the plots around. This is just your one final look at these regressions and whether or not you're satisfied with this ablation interval. When you are, you can hit this enter sample name, type in your sample, whatever it is. I'm just going to say 91,500. And then either hit enter or click out of the box and hit accept sample name. And you should see it populated now down here. Okay. As you continue going through your data, let's say, let's say you want to advance all of these sliders to the next analysis. An easy way to do this is just to set this jump time, which should be the jump between analyses. So that's background plus washout plus ablation interval. Okay, so it's probably something like 58 seconds. Okay, all those sliders should advance. Okay, you can see we got pretty close. Okay, and then you can adjust using the arrows from there, or typing, or sliding the sliders, whatever you want to do. So I'm going to just do my next analysis here. For all intents and purposes, let's say that's 91,500. Again, you can see those fitted regressions, all that nice stuff. Hit accept sample name. And you can see that we automatically number those sample labels. Note that the measurement index, which is used to correct for drift, is going to automatically increase by 1 on every single one of these analyses. So if you do decide that you want to try 2 different intervals for the same analysis and compare and contrast, maybe you see something kind of weird. You can see these intensities change. This crystal's a bit zoned. You can see that in the ratios. Let's say you wanted to try both. Let's say you wanted to try only taking the first 10 seconds versus taking the whole interval. You would have to come down here and manually change that measurement index, or else you would incorrectly correct for drift in the second part of this program, which I will go over in the next video. And when you're done, by the way, hit this green button, go to laser tram Z. Okay, we're going to do, oh, here we go. And you should get this file, which is input into the second part of this program. And when you do get this file, go ahead and delete this first column, save that, and it's ready to go into the second part. And how do you stop this thing?